we are going to bust out some probability here with equally likely outcomes. Now, I want to kind of draw your attention to that first. When we talk about equally likely outcomes, we are now talking about theoretical probability, okay? Assuming that whatever we're dealing with, there is an equal chance of every outcome having the same ability to happen. I think I just talked in circles, and that's okay. So let's go back with the definition of probability. All right, and there's a couple ways that you can think about this, but basically you've got the number of ways whatever you want to happen can occur, okay? The number of ways, so this is what we want to happen over the total number of ways. I don't like that definition. Let's back up. Let's use Becky's definition. When I try to put my definition with math definitions, it just never works out. So what we want to have happen, how many times is that possibility? That's what on the top. And this is total chances. All right, that's kind of the Becky definition of probability. What we want, how many times is that possible? Okay, now let me do an example to show this. So what we want on the top, total things on the bottom. Jessie throws a 6-sided die. What is the probability she tosses a number greater than 4? Okay, so remember, our probability is what we want over the total number of chances that things can actually happen. Now, usually the total is the easy part. There's a 6-sided die. If she's throwing it one time, there are 6 possibilities, right? A 1, 2, 3, 4, 5, or 6. 6 options. So how many options do we have that are greater than 4? Well, greater than 4, that's a 5 or a 6. That means there are 2 options greater than 4. So 2 goes on the top because that's what I want to have happen. There are 2 options of what I want. So my probability reduced, because we are great mathematicians and we reduce our stuff, is 1/3. Let's go to the next example. Bill flips a coin. What is the probability it's a heads? Okay, let's think about this. We're flipping a coin. Again, we're talking about what we want over the total. So the total, we're flipping a coin. I don't know about you, but every coin I've ever seen only has 2 options. You've got a heads of a type, you got a tails of a type. So you got 2 options. So what is the probability that it's a heads? Well, generally, there's only one heads, unless you have a 2-headed coin. And in that case, it's totally not fair. So let's say Bill flips a fair coin. We have a 1 out of 2 chance, right? 50-50 for flipping a heads, theoretically. John shoots a free throw. This is my favorite example. What is the theoretical probability he makes it? Now, think about this. You're playing basketball. Here's the hoop. I don't really know what that means. And then you have a basketball and you toss it into the hoop, right? When you toss it towards the circular hoop that is a basketball rim with a net generally, you basically have 2 tries. There are two possibilities. You either make it or you don't. That's it. Those are your options. It either goes in through the circle or it stays outside the circle. There are no other options. So theoretically, we have 2 options. And what's the probability that he makes it? Well, there's 1 chance that he makes it. So basically, shooting a free throw, every time somebody lines up, we got a 50-50 shot of that basketball going in. That's theoretical probability. When you watch the NBA or high school basketball or college basketball, whatever, and they throw out like his free throw percentage is 67%, that's empirical probability. That's a different video. Theoretical probability is assuming that everything has an equal chance of happening. It's an equal chance of making that basket and not making that basket. Those are 2 complete, like either one of them can happen. Theoretically, John has a 1 out of 2 chance. And the last one, Betsy looks at the first multiple choice question on the test and is stumped. There are options A, B, C, D, and E. What is the probability she guesses correctly? We must assume that only one answer is correct. Okay, so again, we're talking about what we want over the total. Betsy has 5 options to choose from. 1 of them is correct. So the probability she guesses correctly is 1 out of 5 because only 1 of those answers is correct. So she's got a 1 in 5 chance of guessing the right option. Good luck, Betsy. Hope you do well.